All right, so this is technically part 3 of your final exam review. We're going to jump around a little bit within these PowerPoints. I'm using the PowerPoint from last year, and I've taken some things off of your final and put different things on your final because we cover just maybe a little bit of a different emphasis this year. For example, you guys learned systems of equations this year. The honors class last year did not learn it. Okay, so technically that's not in your book, but it's in the standard pre-algebra book, and it's really important for Algebra 1. So all that being said, we're going to kind of go through here, but we'll cherry pick off some of the questions. So to translate a point, if I'm going 3 units left, am I adding or subtracting from x? If I'm going left, I'm subtracting 3. If I'm going 2 units up, am I adding or subtracting from y? I'm adding 2. All right, so did you guys get 1/8? Yeah. Okay, now to describe the translation, I have to figure out if from a positive 6 to a positive 2, which way I would move on the number line. So which way would I move? I would move to the left, how many places? All right, so left 4 units. And to go from 5 to 8,
up 3.
I go up 3. You guys doing okay so far?
I don't know
All right, so this next one looks real fancy, right? You're like, oh, lines X and Y are parallel. Well, I want you to picture what that looks like on a graph, right? They're just parallel. So if they're parallel and the same transformation happens to both of them. So that's the important part here. You're going to have a question on your final that says, what if, for example, what if I were to translate both lines? What if I were to rotate both of them? Or dilate? Technically you can't dilate a line, but if it was a shape, okay? If the same transformation happens to both of them, guess what? Their images will also be parallel. All right, now, if I were to translate one line and reflect another line, are they still parallel? No, okay? But if the same transformation happens to both, then yes, their images are parallel. All right, okay, next one. In order to solve this, you have to know the sum. What is the sum of the angles of a triangle? 180 degrees. Okay, so when I add the other ones together, they should all equal 180. If I put that into an equation, I can now solve for x. 42 plus 56 is 98, plus x equals 180. What would be my last step to solving for x? Yep, minus 98 from both sides.
72?
Almost.
82.
Yep, x equals 82. Now, the trick to this last question is knowing the formula for circumference. What is my formula?
C equals 2 pi r.
C equals 2 pi r. C equals 2 pi r. So multiply 2 times 3.14 times whatever your radius is. And what would that be?
31.14.
31.4, right? Should it just be 31.4? And it's...
Oh, yeah, 31.4.
Yeah, it's not pi r squared. Pi r squared is area, but we are about to do an area one too. Okay? So just get your formulas. The formula is going to be really important. A lot of different formulas that we're going to have to review today. All right, next, proportions. Okay, so now we're throwing it back to chapter 5 with proportions. With proportions, I have to have an equal sign, and I have 2 ratios being set equal to each other. So here's the important part. Whatever I put in the numerators, they have to match up. Whatever I put in my denominators, they have to match up. So before I tell you what it is, I just want to give you guys about 30 seconds to see if you can plug in the numbers, where they go before I tell you. All right, I might hold off on solving just because if you put them in the wrong spot, if you're really sure you put them in the right spot, you can keep solving. Otherwise, you might want to wait. Okay, so what did you guys put in your first ratio? I would have done 5 over 8 too. So 5 over 8 is height over shadow. Do you see that? It says a tree is 5 feet tall. So 5 is the height of the tree, and it cast an 8-foot shadow. So when you read the next sentence, that helps you figure out where to put the 12. A nearby building cast a shadow that is 12 feet long. So where does shadow go, top or bottom? It goes on the bottom. All right, now remember, your exam's multiple choice. So don't you think I would flip it and do that math, and that would be one of the choices too? So you're going to have to really be confident in where you put the value, because the other answer options are the common mistakes, okay? All right, 5 times 12 is 60. 8 times x is 8x. Don't be afraid of your answer being a decimal. All right? A building can be 7.5 feet tall. It's a super tiny building. I mean, right? Like 7.5 feet, maybe it's like a little playhouse or something. I don't know. 7.5 feet is super short. Any questions on setting up your own proportion? Like I said, these questions are like one question on your final. All right? Or maybe 2. But it's,
I can't remember is the reflection, like 90 clockwise.
you won't have to know the rotations for this final. You will have to learn them in Algebra 1, but you won't have rotations on your final exam. Okay? You will have some of the other ones, but not the rotations. All right, next, we need to hit on some exponents. Like I said, this is kind of surface level today, and then we're going to revisit all these concepts and do a lot more practice. For now, I'm just reintroducing you guys to these concepts. So over on the left-hand side, we've got some of our exponent properties, right? You have to remember, when do you add the exponents? When do you multiply the exponents together? When would you subtract them? Also, what would you do with a negative exponent? We can't evaluate until we can make it positive. So we're going to pause here just for 2, maybe 3 minutes, let you guys work these problems, and then we'll come back and solve them. Okay, you guys ready? Which property did you use to solve the first one? What was it called? Yes, but what was it called? No. Product of powers. So here's why I'm asking you that. What if you have a question on your final that I say, which one of these expressions is an example of product of powers? And let's say you had these 3 choices. Would you be able to tell me the first one was product of powers? Okay? And, okay, so look at the second one. What property is the second one? You might know the math, but do you remember the property name? The
Multiplication of powers.
Power of powers. Okay, here's why it's power of powers. Because you have one base being raised to a power, then being raised to another power. So that's where we get the power of powers. Now, am I multiplying these? Am I adding them? What am I doing? I'm multiplying them. So you need to know more than just the math. You need to know what it's called. All right, so what's the first one called? Product of powers. What's the second one called? Power of powers. What's the third one called? Quotient. So don't you think possibly another answer choice would say division of powers, but we don't call it division of powers, call it quotient. So make sure you get those. Hopefully those will be some of your easier ones to solve. All right, so h to the what, guys? Y'all tell me.
To the third.
H to the third power. Now, I cannot evaluate a negative exponent. Somebody raise your hand and tell me, what do I do to make the negative exponent positive?
Put it over.
Okay, I asked for hands, guys. Raise your hand. Destiny, what do you think?
Flip it, like, put it in front.
Yep, very good. And flip it down into the denominator. My rule says when I put the expression in the opposite side of the fraction, it makes my exponent positive, or it makes it the opposite sign. Now I can evaluate. This is 1 over 256. Okay, you will be allowed to have your calculators on your final, so you'll be able to just do that math in your calculator. Okay, next one. What if I gave you these 3 answer choices? All right. Do you see the correct answer?
Yes.
Do you see it? Which one is it?
Third one.
Middle one. Third.
It is the last one. Because remember, you're raising every term inside the parentheses to that power. So it's not just, oh, my parentheses go away, or it's not 3 times 3 equals 9. It's the base times itself that many times. So that's why the third option is the correct option. All right, so I just want to get your minds thinking. We're now about a week away from your final exam. All right? Multiple choice is a different kind of test because sometimes you might be looking at one of the answer choices and sometimes you might be looking at all 3 of them and say, I don't see the correct answer here. And you have to be confident enough to choose none of the above. All right, so that's going to be a really important strategy that you take going into your final exam. All right, we need to review scientific notation. In order for a number to be written in scientific notation, the decimal value has to be between 1 and 10. Between 1 and 10. So I want you guys to shift your decimal to a value that gives you a number within that range. And then remember, with scientific notation, we times it by a power of 10. Okay, what is the decimal value? Y'all tell me. What's the decimal going to be? 6.24. All right, 6.24, which means I have shifted my decimal all the way here behind the 6. So I have to count how many place values that is. All right, how many place values did I move my decimal?
6.
So it's 6.24 times 10 to the negative 6 power. What do you think is going to be another answer option?
10 to the 6th power?
10 to the positive 6 power. But I know it's negative because this is a really tiny number. So again, you have to remember, when do you make your number big? When do you make your number small? All right, Trey, what's going to be my decimal value in the last number? Very good. 468. Is this basically, guys? You're putting it after the leading digit. Okay. Is this number within the acceptable range? Yes. So now, don't count how many zeros, because my decimal is not after the 8. It's not how many zeros. It's how many place values do I move to get to the new decimal location. Mikhail, what do you think? 10 to the 11th power. Do you guys see why it's 11, not 8? You're not counting zeros. You're counting place values. It's really important for your final. All right, next one. Evaluate. Write your answer in scientific notation. So don't take the numbers out of scientific notation. What operation is happening between the numbers? What operation do you see? It's addition. So when I'm adding and subtracting, what do I need to check for?
Common bases.
Not common bases, but common powers, common exponents. Do I have a common power? Yes. So that means that's like having a common denominator. That means that I can add my decimals together. All right, so go ahead and do that. Here's the catch. Make sure your answer is written in scientific notation. Fully. Okay? All right, give you a minute to work on that one. Okay, so what is 9.2 plus 1.4? 10.6. And then we bring down our common power. Now, 10.6 is too big. Did you guys catch that? My rule says if I bump my decimal to the left, what happens to my power? It increases. All right, so 1.06 times 10 to the 5th power is my answer. All right, so now we're going to shift gears over to some of your 7th grade standards that we learned in semester 1. Yeah, I know. Okay, so I'm actually going to shift over here to I'm going to skip the exponents one.
Probability.
Scientific notation we don't need again. Where did it go? Oh, there it is. Proportionality, don't need that one. Probability. All right, it's just 2 slides from this PowerPoint that we need to go over.
Oh.
All right, so probability is going to be one of them. Is there 3? Okay. So out of these 3 questions, only the middle one is on your final exam this year. Okay? So the first one is percent error. That would be the margin of error divided by the actual amount. We don't have to do that one. The second one is going to be our focus for today. Let's read it together. It says there are 15 red cards in a deck and 25 black cards. You randomly choose a card. That should say card. You randomly choose one card. What is the probability that you would choose a black card? So, fundamentals of probability, and for whatever reason, they love probability and statistics on your standardized test. The MAPS test, the SAT, the ACT, the state certification exam that math teachers have to take, it's like full of probability. I don't know why, but it's really important. So we dive deeper into that as you guys get into high school. For this year, we're just kind of scratching the surface. Probability, and remember what goes in parentheses. It is your targeted outcome. What are they asking you? What is the probability what? That you will
pick a black card.
Pick a black card. So probability that it's black, okay? That's the focus. So how many black cards are there?
25.
25.
Out of
Out of how many total cards are in the deck? 40. How did you guys get 40? I don't see a 40 in the problem. Because if there's 15 and 25, that makes 40 total cards. Okay? Now, your answer options will be percentages. So when you divide this, you will get 0.625. But that doesn't really mean a whole lot to us, right? If I say the probability that I would choose a black card is 0.625. No. Is that how I would describe the rain chances?
62.5%.
It's 0.625 chance of rain today. No, I would say 62.5% chance that I would choose a black card. All right. Okay, any questions? Any questions on the probability? So again, surface level today, more practice coming throughout the rest of the week. Percent problems. Both of these. We're going to need to practice this probably a little bit more than the other concepts. But again, we're touching on it today. And it's on your review sheet homework tonight. What is the selling price of a $25 item when it is marked up by 80%? I need to give you guys a couple reminders. The first one is your formula. I want you to use the percent equation. A equals P times W. I need to remind you what each letter means. And this is the part where it might be helpful if you go back and watch the video. A stands for what you pay. The selling price, what you are paying for that item. If it's a discount, it's the price you're paying after the discount. If it's a markup, it's the price you pay after it's been marked up. A is what you pay. P, this is important. P is the percentage that you pay. We'll talk about that in a second, how we're going to write that. W is the original cost of the item. All right, so now that we have a reminder of what each term means, what am I solving for? Am I solving for A, P, or W?
W. P.
I am solving for A. A is the selling price. It's the amount of money that you're going to pay on a $25 item when it is marked up by 80%. So A is what you don't know. If it's marked up by 80%, this is the part that's going to be tricky for you guys. That means, all right, 100% is just the cost of the item. If it gets marked up, that means you're paying more than 100%.
180%.
If it gets marked down, okay, so let's say you buy something for 20% off. That means you paid 80% of the original cost. So if it's marked up by 80%, this is 180% times the original amount. Now I'm writing it as a percentage to help you guys see. The original amount, I am paying 180% of that. But before I can multiply, I need to change my percent to a what? Decimal. Guys, you can do that in your work. You don't have to write it as a percentage, but I'm just showing you that's what's happening here. Does that make sense? I know I keep asking if it makes sense. It seems like you guys are following along okay. All right, so A equals 1.8 times 25. All right, so what is 1.8 times 25? Anybody have a calculator handy? Okay. So the amount you pay, does that make sense based on the other information?
I did it where
What, the proportion?
A over.
That's fine. As long as for P, did you plug in 180?
Yeah.
Now, if you do that, don't change it to a decimal because it's already over 100 and you'll get the same answer. All right. Does that make sense? If it's marked up that I would pay more than the original price. Yeah, that makes sense. So I can make sure that my answer makes sense. Next problem. Guess what? You got to remember the formula. Does anybody remember? Raise your hand. Nope. Raise your hand. What is the formula for simple interest? Haley. I equals P R T. Say it with me. What does I stand for? Interest. What does P stand for? Principal. The original amount, the chunk of money that is either borrowed or invested. What does R stand for? Rate as a decimal. What does T stand for? In years, not months. Okay, so time in years and not months. So it says, how much did you pay in total after the loan was paid off? We're going to pause here for a minute. I want to see if you guys can plug in the numbers. And you can go ahead and solve the problem also if you guys feel confident. So go ahead and just try to plug in your numbers, where they go in the formula, and answer the question. All right, so I equals, what number did you plug in for P? 1200. P is the principal. What number did you plug in for R? 0.05. What number did you plug in for T?
What does I stand for?
I is the amount of interest that you make.
It says interest right there, 5% interest.
But 5% is the rate. Okay? All right. So what is 1200 times 0.05 times 3? No. $180. All right. This is going to be one of your answer options. If this was a question on your final, this would be an answer option. But it is not the answer to the question. How much did you pay in total after the loan was paid off? You did not pay $180 total. Because what do you have to add it back to? The $1,200. You borrowed $1,200. You paid back the $1,200 plus another $180 in interest. Does anybody remember? I see it on a few. What is the letter that stands for the final balance? A. Remember, it's that random letter, A. There's actually another formula you can use that takes you straight to the final balance. So you don't have to add the two together at the end. But it's unnecessary for this level. So A equals $1,380. You guys understand how we got to 1,380 and why? If you borrowed $1,200, you're paying back the $1,200. And whoever you borrowed it from just made $180 in interest for fronting you the money, giving you the money up front so you could purchase the computer. Okay, circles we've already gone over. Circumference is going to be the one that you need to know for your final. And we've already gone over transformations as well. So that's going to wrap it up for part 3 of our exam review. We'll pick up tomorrow with rational numbers and wrap up our review.